Okay, here's lesson 2 of Cozy Notes for the week of December 1st. In this lesson, we're going to talk about solving inequalities with multiplication and division. This one is a little bit more complicated than solving with addition and subtraction. So we have to do an experiment first. We have to try something out. So I'm going to put 4 inequalities up here. Please jot these down so you can follow along. All right, so let's use what we know. We know that when we solve an inequality or an equation, we're trying to isolate the variable using opposite operations. So let's undo multiplication of 3 by dividing by 3. Then we have n is less than 2. Let's graph that on a number line. Benchmark of 2, open circle, n is less than to the left of 2. Let's pick a number under 2. Let's say 0. If we replace n with 0, is that less than 6? We put that back into the original. 3 times 0 is 0, and 0 is, in fact, less than 6, so we know we are correct. We know we're good, so we can go back and put solution set notation around our solution. Let's try that in the next one. We're going to divide both sides by -3. When we divide or multiply, the sign goes with. We end up with n is less than 2. Let's try that out. We have 2, we have an open circle at 2, and where are numbers under 2? Numbers are under 2 to the left of 2. Let's pick a value. Let's go with 0 again for the sake of ease. We put 0 back into the original, -3 times 0. Is that less than -6? -3 times 0 is 0. Is that less than -6? The answer to that question is no. 0 is not less than -6. That's not true. So what we have here is wrong. So we have to decide, well, we didn't do anything wrong when we solved. So why doesn't this make sense? It comes back to our understanding of what a negative means. A negative means change. The negative sign changed directions or changed sides of the inequality. When we multiply or divide by a negative, it's a command to change directions. Think about a teeter-totter. If the left side was less than, and that direction to change directions was on the left side, and we brought it to the right side, it's going to tip the teeter-totter. It's going to reverse the direction of the teeter-totter. So we need to change the direction of the inequality symbol when we multiply or divide by a negative. We end up with n is true when n is greater than 2. Let's try a number greater than 2. Let's graph it and see if our solution set now works. We have 2, open circle at 2, to the right of 2. Let's erase our other example here. A number bigger than 2, we can use 4. So let's try 4. -3 times 4, is that less than -6? -3 times 4 is -12. Is -12 less than -6? And the answer to that is yes. Therefore, we know we are correct. In the next one, we divide both sides by -3. We end up with n is less than -2. Let's try that on our number line. -2, open circle to the left. Pick a number under -2. Under negative 2, we can go with negative 4. Negative 3 times negative 4, is that less than 6? Negative 3 times negative 4 is a positive 12. A positive 12, is that less than 6? Nope. So this is wrong. Well, why is it wrong? It's wrong because we divided both sides by a negative. So that command to change direction, change sides of our teeter-totter, change sides of our inequality. So we have to change the sign of our inequality to follow the command to change that's in the negative 3. We have n is true when n is greater than negative 2. Let's test to see if that worked. So we'll regraph it. Our number line, benchmark it in the negative 2. Now we're saying that n is greater than negative 2. What's a number greater than negative 2? We can go with the number 1. Negative 3 times 1, is that less than 6? Negative 3 times 1 is negative 3, and negative 3 is less than 6. That is true. So we've done a good job, and our solution set is now finished. So now we have our answers emerging here. But we have to make sure that we understand when do we have to flip the inequality symbol, and when don't we have to flip the inequality symbol. Let's try this last one. Divide both sides by 3. N is less than negative 2. Let's try it out. Negative 2 as a benchmark. Under negative 2 is our answer. Let's choose a value below negative 2, like negative 3. Let me erase this so I have a little bit of space. 3 times negative 3, is that less than negative 6? 3 times negative 3 is negative 9. Is that less than negative 6? Sure is, so this answer is correct. So we can have our final answer of n is true when n is less than negative 2. No change needed. So let's summarize. So we can have a good rule to work with. In the first example, we divided both sides by a positive 3. A positive means no change, so we don't have to do anything special. In the second problem, we divided both sides by a negative 3. A negative means change, so we had to do something special. We had to flip the inequality symbol. In the third problem, we had a negative change sides. Because we had a negative change sides through multiplication or division, in this case division, we had to flip the inequality symbol. Because that direction, that command to change direction, switched sides. In the last example, we divided both sides by a positive 3. A positive means don't change. Keep it the way that it is. So the only two that had adjustments are when we multiplied or divided, in this case divided, both sides of the inequality by a negative. The other ones stayed the same. So I don't know what the symbol for stay the same is, but we'll just put a stay. We can test that with division as well. It will be the same story, but why not? Make sure it's thorough. So we have 3n, or excuse me, let's do, we want the variable in the numerator, not quite ready to have the variable in the denominator yet. Let's have n divided by 2 is greater than 4. N divided by negative 2 is greater than negative 4. N divided by negative 2 is greater than a positive 4. And last, N divided by 2 is greater than a negative 4. So we have all of them covered. All possible combinations covered. When we solve with division, The opposite of dividing is multiplying. So we're going to multiply both sides by a positive 2. A positive means stay the course, no change. So we don't flip the inequality symbol, it stays the way it was. But let's check to make sure it's true by graphing it and trying it. Benchmark of 8, n is greater than 8. So let's pick a number that's divisible by 2 that's easy to work with. So let's say 10. If we replace n with 10, 10 divided by 2, is that greater than 4? 10 divided by 2 is 5, and 5 is greater than 4, so it checks out. All good, we were right. In the next problem, we're going to multiply both sides by a negative 2. We multiply both sides by a negative 2, we end up with n, and then we have negative 4 times negative 2, which is a positive 8. Because we multiplied both sides by a negative 2, the negative 2 changed sides, therefore the inequality symbol has to change directions. It was greater than, it now becomes less than. N is true when n is less than 8. We flipped the inequality symbol because the negative changed sides through multiplication by a negative. Let's graph it to check. We have an open circle. N is under 8, so let's pick a number under 8 that's easily divisible by 2. So let's pick 6. 6 over negative 2. Is that greater than negative 4? When we test it, we want to make sure we test it in the original problem. 6 divided by negative 2 is negative 3. Negative 3, is that greater than negative 4? It is. Barely, but it is. So we know our solution set is correct. All right, the next one. In order to solve the next one, I'm going to erase this so I can see it. We're going to multiply both sides again. In this case by a negative 2. And n is greater than negative 8. But then we ask ourselves the question, a negative sign changed sides using multiplication. Therefore, we have to flip the inequality symbol. So let's erase the one we had and put in a less than sign. And then let's test it out before we put in solution set notation. We have negative 8 as our benchmark, and we're looking for values under it. What's a number under negative 8? How about negative 10? Negative 10 over 2, negative 2, is that greater than 4? Negative 10 over negative 2 is a positive 5, and 5 is greater than 4, so it checks out. We are correct. So we can put this in solution set notation. N is true when n is less than negative 8. All right, last but not least. In this case, we're going to multiply both sides by a positive 2. I didn't realize that 4 had such a long bottom on it. We end up with n is greater than negative 8. We do not flip the inequality symbol because we multiply both sides by a positive 2. Positive means no change. But let's check it just to be sure. Negative 8, closed circle. N is greater, therefore to the right. And let's pick a number that's easily divided by 2. So let's do a positive 8. 8 over 2, is that greater than negative 4? 8 over 2 is a positive 4. Positive 4 is greater than negative 4, so we know we are correct. And then we can put it into solution set notation. N is true when n is greater than negative 8. Bottom line, if you multiply or divide by a negative, flip the sign. So this one changes and this one changes because we multiplied both sides by a negative. This one stays because we multiplied both by a positive, and this one stays because we multiplied by a positive. So let's try a couple. Negative 12n is greater than 36. And another problem, 14n is less than or equal to 28. Which one of these are we going to have to flip the inequality symbol? If we ask ourselves that question, we want to pay attention to the coefficients. The coefficient here is negative. The coefficient here is positive. We only flip the inequality symbol if we have to eliminate a coefficient that is negative. So this one's going to get the flip on the right-hand side. Don't flip over here. All right, let's divide both sides by negative 12. We have n is less than, because we have to flip, negative 3. I recommend highlighting or circling the inequality symbol to remind yourself that you've taken care of it. Because when we end up with multiple step inequalities, you potentially could have to flip the sign more than once. N is true when n is less than negative 3. All right, over here, because our coefficient on the right side is positive, we do not have to flip the inequality symbol. A command to change signs did not switch sides, so we leave it alone, and we end up with 2. N is true when n is less than or equal to 2. Do one more example with a set of quotients. So let's take a look at and then let's put one, this is a little bit crazier, ever so slightly crazier. And let's compare. All right, look to the side with the variable. The variable on the left-hand side is being divided by 4. The opposite of division by 4 is multiplication by 4. The 4's cancel. We're left with n is greater than negative 48. A negative did not switch sides through multiplication, so we do not flip. On the other side, we look to the side with our variable. We need to isolate our variable. So we're going to multiply both sides by negative 4. Our variable is still on the right side, but if we noticed, we multiplied both sides by a negative 4. It switched sides, so we have to flip our inequality symbol. We're going to flip it, and instead of the less than symbol, we need the greater than symbol. And 4 times 16, we have 24, 64, negative 64. We can't put this one in solution set notation, though. We can't put it in solution set notation because the n must go first. When we read the n is on the less than side. So n is true when n is less than negative 64. We didn't put the other one in solution set notation. I'm going to go back. Now let's make sure we have the complete picture here. So we had to do two different things. We had to flip the inequality symbol. We had to flip from less than to greater than. And then we had to rearrange so that the variable is first. And there we have it. Good luck, everybody, on your homework.